like a me. So I had to take apart a bunch of laptop batteries that I got on eBay for around $500 after shipping for a little over 100 pounds worth of laptop batteries. I've not actually weighed the batteries to see how much the batteries themselves weigh, but I'm guessing they're about 80 pounds worth of batteries. And it seems, with rough math, about 800 batteries total. So I'm hoping for a yield of over 500, but I'm aiming for my pack to be using the best 400 batteries. So I'm going to run a 4S 100p lithium ion setup. And I'm hoping draws a low enough rate where I can go 4 hours on a 4-hour trip without running the lithium batteries completely dead, without ever using the alternator. So here are all the batteries, power control boards that I pulled off, and there was 6 of these battery containers full of batteries before I started processing. So as you can see, there is 2 of them missing. One wasn't quite full, but the other one was, so about, I guess, 5.5 batteries total. Over here you can see my tub for 1.9 plus batteries. So these are the cream of the crop batteries, which will later be sorted after finishing off the batteries. These are the less than 1, or the complete duds. As you can see, the one on the top is very rusted. Over here is the batteries that are semi-okay, but not cream of the crop. Over here is the charging station I built out of modules. So here's my newest project. It's going to be a battery welder, spot welder. So what I did was took 2 tips, conical tips, which are pretty much worthless and they come with most soldering irons. I just had them laying around, conical soldering tips. So anyway, this is going to give me a voltage of about 260 max. So the plan is have a bridge rectifier over a 240 volt input, and then run the output of this pack, the DC output, to the relay that's going to be triggered by this relay. So this relay will hit the high amp relay, probably going to end up being a starter solenoid. And right here I have these electric probes. Now the plan is I'll have some nickel and I'll be able to weld the batteries with a high current weld. And somewhere around here, yes, I've got nickel plate. So there's the nickel plating, and I'll practice with some of the bad batteries first and with some of the bad nickel that, I salvaged from the old packs. And hopefully that will weld. And if that doesn't work, I have a microwave transformer that's been salvaged. I just need to get 2 gauge wire or whatever to wrap around it a couple times, so I have low voltage high current directly from the mains. But I'm hoping these caps will work better than the AC power would. So just 2 different methods to test. Whichever one works better will be what I use for building the pack. And I stuck 2 wires. This was the closest gauge where I could fit 2 of them in the end of the soldering. And I think this is 18 gauge? 16 gauge? So anyway, no, 10 gauge. Kind of hard to see on the, easy to see on the red. But anyway, so this will be my contacts for touching up against the battery when the nickel plate is over top of it. So I'll put the nickel plate over top of the batteries and then make the contacts close and touch them on. And then I have a foot pedal, which when the foot pedal is stepped on, it discharges this capacitor. And the capacitor discharges into this Arduino relay apparatus here, which turns the power to the relay on. It doesn't turn the controller on. I have the controller so the relay is always being controlled to on. This turns the relay on because this is a negative based. It's a zero state activator. So then here is the positive value that turns the relay on. That relay will output to a larger relay, a high current, probably a solenoid off from a starter engine. They can handle quite some current. I'm not sure what's going to happen when I have high voltage going through it. We'll see about that. Anyway, so this is a 470 farad. I had around, or microfarad, 470 microfarad, and I had around a 200, no, a 100. I think 100 is the next size down I have, 100 microfarad. And it would not activate the relay. So this is the next step up. It will activate the relay, and it shuts off a little bit after it turns on. I have not measured the delay, but if I need less of a delay, a smaller, because it's supposed to be like about a quarter of a second to do a weld, I will just get like a 250 or 220 farad, something like that, maybe a 300 microfarad. And then, yeah, I just have it on a proto board. This button was to activate the thing, but I disconnected it by moving the wire and having a jumper jump that connection straight across. So that's just for testing purposes. And that is all there really is to that. I'll just have a... So capacitor charges up. When this button is not stepped on, when it steps on it, it discharges the capacitor through the relay. And that's all there is to it. So as far as taking the battery pack off, I found that on the weaker ones, the laptop batteries, you can twist them back and forth and kind of crack them. These things I got at a garage sale for real cheap. I don't know what they're called, but they're fencing pliers for, you know, like chicken coop and stuff like that. Anyway, that's what these are for. These work really well for crushing the packs and like twisting them off. Sometimes I stick a screwdriver in to get them off. I don't have any battery packs left. This is my last one. And I try to do it in like a factory process where I do one step, then the next step, and then the next step. So I'm just going to demonstrate. Flush cuts work really great. You want to disconnect the voltage so that you're not shorting across them as you're working on them. Scissors was what I was using before. These work for most things I do. And then I already cut parts of this. No, I'm thinking of a different pack. So yeah, I just tried to cut without cutting across, because if you cut across, you'll get smoke if it's a decent pack. Which it's not a terrible thing for... It's hard to work around the camera. And if you don't want to put smoke in your house, you just try not to cross sleeves across each other. Just prying them apart seems to work for me. Then I take the pliers, I get them as close as I can, and I roll them, then I grab them closer, and then I roll them, and I just keep doing that until I get the majority of it off. I just work it off. Sticks to the pliers, that's the only bad thing about these pliers. Yeah, those wires don't appear to be going across anything, so... So when you're working with batteries, I found wearing gloves is a very good idea, because I get a cut or so after every, or scratch or whatnot, after every about 10 battery packs. It wasn't until I was halfway through with 800 or so batteries that I'm like, gloves would be a good idea. And since then I've wore gloves for the taking apart the plastic casing. This, not so much. I haven't got injured too much with this. Some of these, I just leave it on because it's too much of a hassle, and I'll deal with it later if it becomes an issue when welding them. Because, to be honest, half of them are not going to be used in the pack anyway, so might as well just take care of the good half and not every single part. And then I just throw those directly into one of the new battery, you know, the two process cell tubs. So yeah, those are separated. So this is the hardest part as far as getting those off. This pack is actually coming apart easy, but some of them will give you trouble. Once you can get them apart and start working them, then it's easy just to slide them across like that. And then when you get them isolated, you then can work them off, rock them back and forth until they're completely off. Now, I am no expert on the subject. I've just started out doing this myself, but I had a friend ask me to show him my process, and this is a demo video of that. So these batteries all here are ready to be put in the tub. And that is my last pack I have. I'll have to buy more if I need more capacity, but I want to build this 400 cell pack. After that's done, I will test it. And if it's got enough capacity to do my 4-hour trips and not underdrain or overdrain the battery, then I will call it success. Otherwise, I'll have to start finding more laptop batteries.